Hey guys, in this video I will show you how to solve company challenges from Uber, so please feel free to add comments and please suggest me a topic for my next video. I hope that you will enjoy watching this, so let's go. So let's start with the first one, the fareEstimator. This one is a pretty simple one. We have this formula here to calculate the cost of the ride, and as input we have ride time, ride distance, and for each car we have its cost per minute and cost per mile, and we need to output the cost of the ride for each car. To start this, we just initialize the resulting array, and then we'll just loop these two arrays, and to do it in parallel we can use the zip function. So for, let's say, let's name this variable per minute, per mile in zip. We use zip here to iterate these two arrays in parallel, and we'll just append this formula to our resulting array. So to do this, we just put this formula here for each car, and then we just return this resulting array. Okay, let's check the tests. Yeah, seems like it passed all the tests. We can submit it. Yeah, this one was the simple one. Let's see what's going next. Now let's take a look at the second problem, the perfect city. In this problem we have a city where streets are laid out to a form of a square grid, and we need to find the shortest path between 2 points in that city. Let's take a look at this picture here. It kind of gives us a hint of a tricky case that we can encounter in this problem, and let me show what I mean. Okay, now let's assume that we have 2 points on the map, for example somewhere here and somewhere here. It's obvious that the shortest path between 2 points will be this one. We just go up, then we go right, and then we go up again. And the length of this path will be the total distance we traveled up, which is the difference of y coordinates of these 2 points, plus the total distance we traveled to the right, which is the difference of x coordinates of these 2 points. The same way we can take 1 point here, for example, 1 point here. The path is obvious again, so yeah, it will be total distance we traveled here plus the total distance we traveled here. Yeah, but for example, if we take 2 points which are on the same block, let's say, I mean the same line, then we can't calculate it the same way, because we can't just go here and go here. We need to go to the street, the nearest street, and then go, oh sorry for this one, and then we need to go back to our point again. Or we can go to this street, go down and go to this point. So it's the only case that is different. So for all of the cases we calculate the distance just like the sum of difference of these coordinates, but for this case we need a different approach. We need to find which path is shorter, the red one or the green one. Same way for the points like here and here, we need to find which path is shortest, this one or this one. Now let's code this. For convenience, I will name these dep and dest. I prefer short names. And as I said, we need to calculate the total paths that we travel alongside x-axis and the total paths that we travel alongside y-axis. And to do that, we just calculate the apps of dep0 minus dest0, and the same for y. Oh, sorry. And the result is just the sum of these two. But as I said, we also need to take into account the cases when the 2 points are on the same lane. And to check if we have this case, we can just take the ceiling of our points. By ceiling, I mean the closest integer that comes after the number. So for example, for 0.9 it's 1, and for 0.4 the ceiling is 1 as well. So the ceilings are equal, so we know that the points are on the same line. So to check this, we just take the ceiling of dep0 and we check if it equals to the ceiling of dest0, and if it is, then we can take a simple approach. We can calculate the paths that will travel by the street which is at x1 in this example. It has the lies on the line x equals 1, and we can calculate the path that we will travel by the road that lies on x equals 0, and then we can just find the shortest of them. So to calculate this, we just need to find this distance plus this distance and plus the distance we travel up. So it's mass ceiling dep0 minus dep0 plus ceiling dest0 minus dest0. Let's name it pass 1, and for pass 2 we'll take the floor, which is 0 in this case. Floor of dep0. So dep0 minus floor plus dest0 minus floor of dest0. Okay, and then main x will be just the minimum of pass 1 and pass 2. And we can do the same for y coordinate. I will just change these values here. Of course, we can make a separate function that will do this job, but we can just change these values here and not waste our time on creating a separate function. And now let's check this code. Yeah, looks like it passed all of the tests. We can submit it. Yeah. Okay, now let's take a look at our next problem, parking spot. In this problem, we have a parking lot with some obstacles, and we have our lucky spot where we want to park the car, and we have a car, of course, and we can move starting from the one of the four sides of this parking spot, and we can move only one direction. So when we choose our side, we can only move in one direction starting from that side. So for example, if we choose the left side as shown in this picture, then we can only move from left to right, and if we choose the top side, then we can only move from top to bottom. And we need to find out, is there a way to reach our lucky spot without running into obstacles? In this problem, it is guaranteed that the dimensions of the lucky spot are different, so we definitely know in which directions we are allowed to move. So, for example, if we have this lucky spot, we know that we can reach it only from the left or from the right. And we need to check if the lucky spot is empty. And we need to check if one of these rectangles is empty. So if at least one of them is empty, then we can reach this lucky spot. And the same way, if we have this kind of lucky spot, which is placed vertically, then we know that we can reach it only from the top or from the bottom. And the same way, we need to check if we can reach it from here. So this rectangle is empty, or maybe we can reach it from here. So this lower rectangle is empty. So now let's code this. Okay, now I will remove these long names. And now I will write a helper function which will check if a given rectangle is empty. So let's name it is empty. So given our matrix and point 1 and point 2. Point 1 is the upper left point and point 2 is the lower right point. Let's check if this rectangle is empty. So we'll loop p1 0 p2 0 plus 1 for okay, and now we check if our load ij is 1, which means is not empty. We return false. And in other cases, we return true, which means that the rectangle given by these 2 points is empty. And so at start, we'll check if our lucky spot is empty. So we check this, if is empty. So, and we need to give this 2 points, spot 0, spot 1, which is the first point, this upper left point, or we can just do it this way, you know? And we need to give the second point, which is the spot. We check if it is not empty, then we return false here. And in other cases, as I said, we need to check if it's positioned horizontally or vertically, and then check if the right and left rectangles are empty, or upper and lower rectangles are empty, one of them. Okay, to do this, we just check if spot 3 minus spot 1 is greater than spot 2 minus spot 0. Then it means that we have a rectangle which is horizontal, like in this picture. So, for this rectangle, we need to check if the left rectangle and the right rectangle, one of the left or right rectangles is empty. So we check is empty. So for the left one, the upper left point is spot 0, 0, and lower right point is, it has spot 2 and spot 1. So, or we need to check if this right rectangle is empty. So, the right rectangle, for the right rectangle we have this upper left coordinate of spot 0, spot 3, and the lower right one is spot 2, and the length of this parking lot, which is, let's take the first row of the slot and calculate its length, and it will be -1. Because we start counting the points from 0. Okay, we need to do the same for vertical rectangles. So, we'll delete this. And we need to enter the correct points here. So, for vertical rectangles, for the upper one, we have this coordinate of 0 and spot 1, and then we have this coordinate of spot 0 and spot 3. Or for the lower one, we have this coordinate of spot 2 of spot 2 and spot 1. Sorry. And for this one, oh, sorry, I saw a problem here. Actually, this one is spot 2. Yeah. And for the lower one, we have length of lot -1, and the other coordinate is spot 3. Yeah, pretty messy, but let's check this one. Looks like it passed all of the tests. Okay, next problem in the list is the fancyRide. This one is pretty simple as well. We have a list of rides for each car here, and we have the length of our ride, and we also have only $20, and we want to find the best car that we can afford. Let's move all of our options in a list. So we take all these options, we put them in a list. Not options. And we just iterate. Iterate the list, and we try to find if we can afford this car or not. So we multiply the length by the fare, and if it's less or equal to $20, then we can afford it. So we can have some variable here for our result, and we overwrite it each time we see a better car. So here, when we see a better car, we overwrite it and we return our result. Let's check the tests. Looks like everything is okay, so let's submit it. Yeah. And now the next problem, nightRoute. In this problem we have n number of islands, we have one-way bridges between them, and we have lengths of these bridges in miles. And we need to find the shortest path between island 0 and island n-1. These kind of problems are solved using Dijkstra's algorithm or its modifications, but if we look at the constraints here, we can see that we won't have more than 10 islands, which means that we can take another approach which is less efficient but which is simpler to code. And let me show what I mean. Now let's suppose that we have this kind of graph. I gave names to the islands for simplicity, and we want to find the shortest route from A to F. So what we can do here is we can just try all of the possible routes and find the shortest one of them. And here is the process. We'll start it from A, and from A we have two possible routes to go, from A to B and from A to D. We'll start with B. So we'll go from A to B, and we'll remember our visited nodes. It's A and B. Then from B we have two possible ways as well. We can go to C or directly to F. We'll start from C. So we go to C, we remember that we visited C, and we continue the process for C. From C we can go to B and we can go to F. Now we check, the B is already visited, so we don't go to B from C. We go from C directly to F. F is not visited. We go to F, we mark this as red, and we calculate the path because we already reached our F, which is 11. And then we go back to C, and we don't have any other way to go from C. We go back to B, and from B we have this possible way directly to F. So we mark this as red. We go from A to B to F, which is 5. And then we go all the way back to A. And from A we go to D. We continue the same process for D. There is only one possible way from D to C. And from C we have two possible ways, to F and to B. But now we can visit B because it's not in the visited nodes. We have A, D, and C in our visited nodes. Let me write this down. We have A, then we have D, and we have C. And from C we go to B first. Go to B, and then we go to F. because we can't visit C from B because C is already visited in the current pass. Okay. And so we calculate this pass. It's 4 plus 1 plus 1, which is 6. So the best one at the moment is ABF. Then we continue the same process. We go back. We can go to C. Then we go back. And from C, we can go directly to F, which is A, D, C, F. And the length of this pass is 7. So, as you can see, the best one is ABF, which is 5. Okay, now let's code this. I will write a recursive function which will give us the length of the shortest pass from the given node to the last node, and will also pass visited nodes to that function, so it will ignore them. So let's write this function. I will name it shortest. It will take city. It will take current node, as I said, and it will take visited nodes. And so the base of our recursion is the last island. So if we are already on the last island, then the distance from the current island to the last island is 0. So if our current island is already the last one, which means it's city, length of city minus 1, which is the same as n minus 1, then we return just 0, because we are already on the last island. And now, for all of the other cases, when we are not on the last island, we need to check the best pass from the current island to the last one. So initially our best pass is none. And now we'll try all of the possible nodes that we can reach from the current one. So it will be enumerate city from current one. And we need to check that the next node is not visited yet. So we'll check if next is not in, just not in visited, and we need to check that there is a bridge to that island, which means that D is not -1. In that case, we can continue our recursion, and we can let's add the next node to visit it and continue our recursion, which means that we will enter the next node and find the best pass from next node to the n, which means that we'll find the pass from next node to n, which will be shortest from city next visited. And after this recursive call, we can pop this node because we already visited it. We can remove it from visited list. And we need to check if there is a pass from next to n, which means the pass is not none. And in that case, we want to find the pass from current node to n. From current node to n, which will be pass from next to n, plus the pass from current node to the next node, which is d. So plus d. And we want to update our best pass, which means if the best pass is none, or our current pass is better than the best one, which means it's shorter, so the current is less than best, then we'll update our best one, we'll set it to current, and then we can just return the best one. Yeah, and of course we need to call this function from here. We'll call it city. The current node is 0 because we start from 0, and the visit nodes are empty initially. So we'll pass an empty set. And now let's check this function. Looks like we have a problem here. Shortest. Yeah, here is a typo. Shortest. We have a problem here. Console output is empty. Expected output or output is null. Okay, let's find this problem now. We set best one to none. We check if our pass is not none. And
2 hours later.
okay, guys, I finally found it. The stupidest thing that can ever happen. Yeah. Whew, finally. Okay, now let's take a look at our next problem, closest locations. This problem consists of two subproblems, let's say, so we can divide it and solve them one by one. The first one is this problem with typos, where we have a user input word and we have our locations, and we need to check that our user input is contained in the prefixes of these locations, but with these constraints, with these limitations, let's say, and we need to check each one of them. So I will create a function for checking these typos. I will name it check typos. I will pass our word to it and location. And in this function, we'll check these conditions. And because we should compare, our comparison should be case insensitive, then we will turn our words to lowercase. And then we'll check the first condition, which is pretty simple. We just check that our word is identical to the prefix of the location. So just word equals to location lens word. We take the prefix of location, and in that case we return true. Now we will check the second condition, and for that condition I will create a function check. I'll name it check, let's say diff. It will also take word and location. And in this case, we need to check that our location is longer than the input word. So if our input word is longer than location, then we return false here. And now we'll say that we don't have a diff, so diff is false, and we'll loop through our words and compare them. Word, actually length of our word. And now we will compare each symbol. So for word I, if it's not equal to location I, then we check if we already have another diff, then we return false because we can have only one diff. And if we don't have diff, we set diff to true, and we continue looping, and at the end of this function we just return true. And we also check this condition here. And if it's true, we return true. And now we need to check the last two conditions when there is a missing symbol or an extra symbol. So let's start with missing symbol. We will have a separate function for that one as well. So def check missing. So we say that we have a missing symbol in word 1. So if we have a missing symbol in word 1, then the length of word 2 should be greater. So we check if length of word 1 is greater or equal to length of word 2, then we return false. And now we say that missing is false, and then we start comparing, but now we will do it with 2 pointers, I and j, for each word separately. So while I is less than length of word 1 and j is less than length of word 2, let's do this. Let's check if word 1 I is not equal to word 2 j. We check if missing, if we already have a missing character, then we return false because we can't have more than one missing characters. And if we don't have missing, we say that missing is true, and because the character is missing in word 1, we just move the pointer of word 2. So we do this, j plus equals 1. We increment it, and then we, at the end of each loop, we increment both I and j. Actually, we need an else here, and then we return true at the end. Okay, now we'll check missing for word, and for location we will take its prefix length word plus 1 and return true. And if there is a missing symbol in location, return false in all the other cases. Yeah, and if there is a missing symbol in location, so for example, at street, and we input cat here, we take the prefix of the location, put it here, and we place our word here. So we reuse the same function, check missing. Yeah. And now let's try to check it on a couple of words. For example, we can take cat from here, and we can take bad building from here. It should say true. Yeah, it's true. Let's take this one. It is true as well. Let's take this one. And it's true as well. Let's like this one. Oh, this one is the simplest, so it will be true as well. And now let's check some other cases where we can get false. For example, cat. We have, yeah, this case. We have one different character. It will be true as well. But if we place t here, we should get false. Yeah, get false for this one. So looks like this part of the problem is solved by this function check typos. Yeah, and we also want to filter all of the locations. So locations are names, right? Yeah. So we will loop for I and name in enumerate names. We'll do this check. The input word is address and location is name. So if it satisfies all of the conditions, we remember its index. So we have our, maybe let's say, an empty set of indices, and we add our index to this set. So let's print this indices. We can run the tests and check for each test. So for example, for this test, the one that was here, all of the indices are here, so it's okay. For this one, they're here as well. Let's maybe check for 9. For 9, both are here. Location, 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 yeah. Looks like for these tests, for this one, cramp is not here because we have a cat here, and for cramp we have 2 differing symbols. So yeah, it's okay. The first part of this problem is solved. Let's go to the second one. Okay, now let's look at our second sub-problem. So the case with buildings is pretty simple because in that case we just need to calculate the distance between the user and the building, which is simply the distance between 2 points. So let's skip that case and look at the case with segments. So we have this segment, and let's say we have our user somewhere here, and we want to find the distance between the user and the segment. So in this case, when the user is standing in front of the segment, which means that the x coordinate of the user is between the x coordinates of the edges of the segment. So in this case, the coordinate is 6, and it's between 2 and 8. It means that our distance is simply the difference between y coordinates of the user and the segment. So y coordinate of the segment is 4 and of the user is 2, so the distance is 2. So is this distance, which is 2. And so we can do the same for vertical segments. So for a vertical segment, let's say this segment, we have user somewhere here, so the distance will be this one, which is 2. But if the user is outside of the segment, so for example our user is somewhere here, or somewhere here, or somewhere here, then we need to find the closest edge of the segment to the user. So for example, for this user, it will be this one. For this user, it will be this one. And for this user, it will be this one. We just check these conditions. If the user is in front of the segment, we calculate it in a simple way, and if he is not, we can calculate the distance from both edges and take the smaller one. Okay, now let's write a function that calculates the distance between 2 points. So let's name it dist. It will take point 1, point 2 as input, and we just do it in a simple way. 0.10 minus 0.20 squared plus 0.11 minus 0.1 squared, and we need to take the square root of this to get the distance. But if we want to work with integers, we can keep all of the numbers in squares. So we'll just keep it in square, and then we'll compare the squares of distances instead of actual distances. So we can name this function distance squared, maybe. And now let's write a function for calculating the distance between segment and point. So we have a point and segment. Now, as I said, we have to check these conditions. So, for example, we will check if the segment is vertical or horizontal. So to check it, we'll just see if segment 0 equals segment 2, which means x coordinates of start point and of the end point are the same. Then in this case, it means that our segment is vertical. And in that case, we need to check if our point is between the y coordinates of the edges of the segment. So to check this, we just do point y coordinate of the point is greater or equal to the minimum of these two edges, which is segment 1 and segment 3, and P1 is less or equal to the maximum of these two. So we take these two and we take maximum of them. And if it is, it means that we will just return the difference, actually the square of difference, as I said, between y coordinates of x coordinates of our point and our segment 0, and we'll take square of this thing. Okay. In the same way, we'll check it for y. So we check if it's a horizontal segment. And here we need to check if P0 is between P0 and 2, P0 is between segment 0 and segment 2, and here we just take P1 minus segment 1. Okay, and now let's calculate the distance for other cases when this point is outside of the segment. Then we just return the minimum of the distance squared between our point and both endpoints of the segment. So at first we take segment 2 and we take other endpoint and return the minimum of distance squared. So now we have squares of all of these distances, and all we have to do is just check. Okay, so which one is the coordinates of our user actually? Oh, it's always 0. It's always 0. So we don't need this 0.2 here. We can just add up squares of 0.1, squares of coordinates of 0.1. But anyway, I already wrote this. I don't want to delete a part of this code, so I will just pass 0, 0 here, and I will pass 0, 0 here. I think it's not a problem. So now we will keep our minimal distance as none, and then for each of our indices, for I in indices, we will take objects I, let's say object, and for this object we will check if length of this object is 2, then it's a point, and we need to check dist squared from 0, 0 to this point, which is object, and we have this dist here. Else, if it's a segment, then our dist will be dist segment from our point 0, 0 to segment, which is object. And then we check if our main dist is none, or our current distance is less than min dist. Then our min dist, we'll update our min dist with the value of dist, and we'll update our index. For min index is none, we'll update our min index with the index of the current object. And at the end we need to return the name of the location, as I remember. So input and output string, the name of the location, yeah. Return the name of the object, the name of the object. So we return names min index. Let's check the tests. We have a problem on test 8. No, we have a problem on test 5. 8 of the tests passed. So what's the problem here? The output is this one, but the correct one is location. Why? Okay, yeah, I know what's the problem. Actually, here, when we are checking for missing, we can do this check of length in a more accurate way. We need to check if it's not equal the length plus 1. If we have only one missing symbol, then the length should be by one symbol longer. So let's check this now. Yeah, looks like he fixed it. Let's try to submit it. Yeah, it worked. That's all for today. Thank you for watching this video. I hope you enjoyed it. As I promised, I will spend more time on this channel, so please let me know what type of content do you want to see. It can be anything from backend to blockchain. It can be a specific problem that you want to solve. It can be a competitive programming problem maybe. So please let me know in the comments, and thank you once again.